Today we have some of our Meta 200 and 400 core team members here. Let me introduce each one. RBG, Tang, raise your hand please, Vincent, and Ruby. We are here to share with the community our progress on the optics at Meta. My name is Qin Wang. I'm an optic engineer at Meta. This is today's agenda. We will cover the Meta pluggable optics evolution and also the 200 and 400G development progress and our sourcing strategies. This journey started in 2017 when we announced 100G CWDM4 OCP optics to support 12.8T switch fabric. Fast forward to 2021, we are happy to announce that we are upgrading our switch fabric to 25.6T. 200 and 400 optics are the two key optic components that support this upgrade. And this will be our main focus for today's talk. In the next generation, we're going to do the 51.2T switch fabric. So stay tuned. So as you can see, in common, in every generation, we try to keep the radix the same, 128. 200G FR4 optics. So first, we want to show you our thought in defining the 200G FR4 optics at Meta. We select the form factor QSFP-56. And as you may know already, today's network becomes more and more intelligent. And we want to have more powerful module management interface for our optics. So for 200 optics, we adopted CMS 4.0, which offered more advanced features, such as RxSNR monitor, loopback control, and also remote firmware upgrade. On the optics spec side, our approach is practical. We leverage the existing 200 FR4 spec in IEEE and optimize the spec around this. Through our analysis, our data center can live with 15 to 65 degree case temperature for the 200 FR4 optics. So we reduce the temperature range from 0 to 70 to 15 to 65 degrees. Accordingly, we are able to reduce the wavelength range from the center wavelength plus minus 6.5 nanometer to the center wavelength plus minus 5.7 nanometer, which allows more flexibility in the RX DMAX technologies. On the TX OMA side, we shifted the OMA by 1 dB to the lower side to support the integrated optics, especially silicon photonics. We also reduced the sensitivity by 1 dB to keep the link budget the same. Our qualification process in 200G starts with a spec definition, followed by a detailed component level and system level qualification done by both the vendors and Meta. The whole systems we used is a Minipack 2, Wedge 400, and also a couple other switches. Our detailed qualification work on both the vendor and our side paid off. This is the key performance metrics of the 200 FR optics in our early deployment. Here we show the distribution of the temperature, VCC, TX power, RX power, and RxSNR. As you can see, for every aspect, we have pretty decent margin. With that, I would like to pass it to Abhijit to talk about the 200G FR4 optics mass production challenges. Abhijit.
Hello. Yep. Hello, everyone. My name is Abhijit Chakravarti, and I'm the tech lead manager at Meta, supporting optics and switch silicon. So as we all know, last year was a very challenging time because of COVID, and the main As a quality engineer, the biggest challenge for us was to do the in-person manufacturing audits. And we were going from development stage to mass production stage for 200G FR4. So we had to go take some innovative approach to perform this manufacturing audit. One of them we introduced is like virtual audit. I would really like to thank all the suppliers who supported us for this virtual audit. I can see some faces here too. Thank you so much. Without your help, it wouldn't have been possible. So what we did actually, we installed several cameras throughout the manufacturing line. And as if we are walking through the line, and we were monitoring each and every processes, like starting from IQC all the way to the finished good product. Everything was under camera. So I'm not saying like it can substitute the in-person audit, but at the same time, at least it helped us to overcome the COVID challenges. So we aligned with all the structured, audit structured what we have in Facebook, so we were able to do that thing. And also the multiple sites we audited in a very short period of time because there was no travel, right? So we were just setting up the meeting. Through all the available software, we were able to see all the production line. And another thing is like, normally when we do the audit, there is only 1 or 2 people we travel to in-person audit. But this time, because of the virtual audit, we are able to get multiple people at the same time, and all those people who were interested were able to experience the manufacturing audit. All right. Yeah, this one. All right. So after virtual audit this year, we all know global material shortages happened, and normally we approve or we accept 1 PCN per supplier for 6 months, but this strategy didn't work this year. So we got like unprecedented number of PCNs, like almost 4x. What we took quickly, we took some strategy to solve the problem. One is the manufacturing ramp enablement for different manufacturing sites, where we worked with all our suppliers closely on manufacturing and the test capacity ramp analysis. Also, we have gone through each and every process yield improvement, like how we can improve the yield. At the same time, we also have checked like how we can improve the throughput, with the partnership with our suppliers. It's like we were able to improve almost some places we were able to improve like almost 50% of the throughput, somewhere 20%. So it was a big win for us. And again, this was like a big thank you to our suppliers. They worked like a partner. Okay. This one is skipping so high. All right, since we are qualifying these PCNs in a record time, so we are taking some risk to qualify these PCNs. So what we have introduced is a long-term reliability for pluggable optics in-house. So as you see in the left-hand side on the top picture, we have our OCP switches loaded with all 200G and 100G, and we are running it for a longer period of time over temperature, like just not only just high temperature or low temperature, it's a temp cycling which we are following. And also we are monitoring the power degradation over time. So we hope like this kind of process will help us to understand the product health moving forward. Right now we have this for 100G and 200G, and we are planning to introduce it for 400G FR4 as well. With that, I will pass it to Thang to go over the 400G.
Thank you. Hi everyone, I'm Thang Pham, optical engineer at Meta. So today I'm like to talk to you about our 400 gig FR4 optic program. So in general, we have very stringent requirement for the optic to be used in our data center. It's very important for us to understand all the requirements, and then we can customize our spec to make sure and qualify to make sure that all the requirements are met before we deploy the optic in our data center. So 400 gig above 4 is the second pluggable optic we are going to use with a 53 gigabit per second PAM430 switch in our data center. So at a high level, it needs to support the Meta new switches such as the WAT400, WAT400C, Minipack 2, and also Arista 7388. In the platform, for some application, we have, in terms of the signal integrity, we have challenging channel more than the typical, more than the VSR or chip-to-module channel has been specified in the standard. So the 400 gig above 4 optic we chose in our data center must be able to support that. Secondly, it needs to be fully backward compatible with our current 200 gig QSFP-56. Not only the PMD backward compatible, but we also able to use either 200 gig module or 400 gig module in 200 gig mode in a single QSFP-DD port without requirement to change the switch configuration or losing the switching capacity. Thirdly, looking to the future, 400 gig above 4 optic we are going to use need to be optically forward compatible with our future 800 gig optic. So with that requirement in mind, we have been developed our spec. We use the latest standards spec as a baseline, such as from the IEEE OIF or the CMIS, and then we customize our spec to align with our DC operational conditions, such as the temperature range, the wavelength range, and the distance and the link loss. And we change the LAN mapping between the electrical LAN and the optical LAN to make sure it fully supports the backward compatibility. Our full spec includes the management interface, EMC, quality and reliability, mechanical. At this moment, we finish the spec development. We plan to share the spec with the OCP community. It is submitted to the OCP committee for review. In terms of the program, we finished the first round of qualification and start deploying in our data center. So this slide shows the key spec, key item of our 400 gig above 4 spec. The form factor is QSFP-DD. Similar to 200 gig, we use CMIS 4.0 to so we can use a lot of advanced feature for our management interface. It can support 2 modes, 200 gig and 400 gig, with a power consumption maximum for that 2 modes is 10.5 and 7 watts. Similar to 200 gig, we also reduce the temperature range a little bit, and we keep the operating range up to 3 kilometers with a 40 dB link loss, similar to 200 gig. Together with the temperature reduction, we also reduce the wavelength range. It's exactly the same as 200 gig, so we keep they are compatible. And the last slide shows our customized LAN mapping between two LAN on the host side and one LAN on one optical LAN on the light side to make sure that in 200 gig mode, it is exactly the same 4 LAN 1 to 4, similar to the QSFP-56 in one DD slot. So with that, I would like to introduce, give to Vincent to talk about our optic reliability and quality.
Thank you, Tan. My name is Vincent Zhang. I'm working on the sourcing operation engineer group for the quality for optics. You know, at Meta, the quality high reliability is our first priority. And then not only for optics, but we require most of our product deployed at our Meta data center has highest reliability and quality. Obviously, it's a long way to go to reach the ultimate goal. So starting from 100 gig, actually, we propose the field target, like 300 of the field as our pluggable optics. And then given the fact is that most of the product deployed at the Meta data center is a new product. So in the first year, we actually increased about 3 times, about 1,000 feed numbers. And then based on our experiences on 100 gig the optics, we know the root cause for most of the failures. So we believe that the reliability is not testing owning the process, but it is owning on the defects control and the process control, and then which will result in the high quality and high reliability. So specifically for 200 gig and 400 gig, we're working with our supply very detailed on the mode hopping, and as well as a laser burning as one of our target. I think we, for the mode hopping, we actually go through very detailed from the wafer level to the COC level and the module level. And then depends on the result, we will reduce the screening of the level. And then after we get into the production, we basically introducing the ORT, as Abhijit mentioned that. The ORT is one of our key things. We want to keep that ORT because we want to avoid batch-to-batch variations on the building the process. And we also implemented our manufacturing anesthetic portal in place for 200 gig and the 400 gig. And then so every unit is, before they send it to the Meta data center, we have their testing data in-house. So that is only the way we can ensure the product meet our requirement as well as a long-term reliability. So within that, I would like to hand over to Ruby for details on the ramp up.
Thank you, Vincent. Good morning, everyone. My name is Ruby Chen, and I'm supporting the Meta sourcing team. All right, so we talked about the technical spec, the requirement for our quality, and also reliabilities. And let's talk about the key metrics that we are driving to address all these challenges that we are facing and what the OCP community can help us with. The first one is the performance as a key metrics. Starting at the 100 gig, we're introducing a multiple technology, laser technology, such as the direct modulated laser, EML, CW laser in the silicon photonic solutions. And it's important for us to continue to carry over to the next generation, such as 200 gig and 400 gig that we talked about today. But we have to be practical because we need to have a sustainable ramp for our optics. So we need to examine the trade-off and understanding all this supply chain complexities for each technology to find the best fit technology. The second one is upgradability. As you heard, that there are going to be a multiple generation in our data center. Every generation will need to be able to interrupt with each other. So it's important to minimize the disruption for the network during all these upgrades. 200 gig will need to work with optical connected to a 100 gig CWDM4 and so on for the 400 gig versus 200 gig. We are also actively looking at forward compatibilities, such as form factor, chipsets, and those are going to be desirable if possible for us. Infrastructure reuse is also going to be very important. Similar to upgradabilities, we need to have a compatible optics to be able to preserve our radix, 128 radix, as well as the fiber cabling. And as a whole solution, how do you fit into our power budget or power envelopes that dedicate to this use case? The last but not least is why we're here is an ecosystem. We're trying to build a interoperable and all this flexible optics into our data centers, and it's important for us to engage from the component on. Okay, all right. So we are proud to announce that Meta has started to deploy the 200 gig and 400 gig optics into our 25.6T terabit per second switch fabric. And as you see on the bottom right chart, our capacity is growing in a historic rate. So we are calling for actions for the community like you. The first one, we encourage you to do the design for excellence for the manufacturability from the component level to the module level, so we can have a secure of supply. The second thing is we would like to continue encouraging you to think about transforming your discrete component assemble like traditional package house to a more advanced semiconductor wafer level advanced packaging techniques. It's important to have the time to market. All this sample availability technology is going to be important with the proven record for the market adoption. Understanding our power, thermal, mechanical, and EMC is going to be the key for the success. And as we continue to quadruple or doubling or quadrupling the bandwidth, it's going to put the burdens or challenge to our optics components. So it's important to have enhanced telemetries and having early detection of the diagnostic capabilities. And nonetheless, that we need to have reliable and hopefully to close to the standard aligned optics as much as possible. All right. With that, we would like to shout out to all the Meta teams. Thank you so much, and also our suppliers that, with you, that's why we're here today. Thank you. And I think we have a couple of minutes for questions. Thank you.
Ruby, you mentioned that you're using different types of technologies, DMLs, EMLs, silicon photonics. How are they performing? What's your favorite? And if you could comment, not only on 200 gig, 400 gig, 800 gig, what trajectories are they at?
Okay, Vlad, great question. We have the whole team here to talk about how they're seeing for different technologies. So any of you want to chime in here?
Thank you for a great question. I think in our optics development, we took a practical approach. We didn't look at every one aspect. We look at every aspect. So we actually were open to different technologies. But I think in the longer run, we saw integrated optics, silicon photonics as the direction that to go in the industry.
Just to answer your question, we are looking, it doesn't matter if it is EML or DML, as long as it is meeting our spec and the product is reliable for next 5 to 10 years, we are good. I think that should be the short answer.
Hi, good morning. Just a question in relation to CMIS4. You said one of the objectives was to enable remote firmware upgrades for optics. I'm assuming that would you treat that as a full recertification of the optic? Because that's something we've traditionally not had to think about, because optics usually would just come with one firmware version and we would never upgrade them again. How are you guys approaching that?
Yeah, so I can take that. So yes, so 200 optics is the first optics in our data centers that support remote firmware upgrade. We view this as a very important feature for the optics. This will reduce the time to market and also give us a lot of flexibility when we deploy the optics in the data centers, right? So the current strategy is this is our last resort to solve critical problems. We don't want to do frequent firmware upgrade, unless something is absolutely broken. But we definitely want to have that capability there.
Okay. Thank you.
Thank you.